Today's kit build, the final kit build of 2024, is assisted by Duck Almond Stout from Brazen Hall Brewing in Winnipeg. They describe it as having a decadent, nutty, smooth, toasted flavor. That is nice and nutty tasting, and roasty too. So I think I will finish the December of kit builds with the largest kit that I've done. This comes to us from our friends at Universal Solder, and it is their clock kit. Specifically, the LED clock kit with melody alarm option for Arduino Nano V3. There is approximately how it's supposed to look when it's done. Or like that. I'm just going to quickly go through what they've got on here. There's schematics and board layouts and everything like that, which is very cool. Down here we have a description. They have some demo code to download and throw onto the Arduino. It talks about some various options in assembly and whatnot down there. And it even comes with a downloadable manual with a full set of assembly instructions. The schematics across 2 pages. Here is the main control board. It's actually on 2 circuit boards. This is going to be a big project. Hopefully I don't drag the video on too long, but let's just get at this quickly here. So we have the Arduino Nano there. We have a bunch of series resistors for the LEDs that are in the segments A through G, just labeled just like any 7-segment LED. And then we have transistors pulling down for the columns. So there's the first column, second, third, fourth, fifth, and sixth. So it'll be just scanning across each of those to save pins rather than driving them all simultaneously. Over here we have the push buttons using an assortment of resistors to set different voltages across that voltage divider into into this analog pin down here. We have a real-time clock module down there. There is that light sensor. Up here is a speaker. This is where a sound module plugs into with a transistor to drive it, and that is all controlled off another GPIO pin. And here's the schematic for the LED board, which is nothing but a whole bunch of LEDs. It's 143 LEDs of both red and green. Are they dual color? I don't know. We'll find out. There is some more of the specifications. It even comes with a 2032 battery. That's nice. So the assembly, it is all through hole, so that's nice. And the first step is what I always do. Start with the parts that have the lowest profile. Resistors, the crystal, a socket, then the transistors, the socket for the real-time clock, the buzzer, battery holder, all that stuff. So that one step is the main board. Just do the parts in order. Right. So here is those 2 boards. The LED board looks like it's got the, what is that, Enig gold plating on the pads. That is pretty classy looking. And since that is going to be the final finished surface facing the world, I like that. That's nice. And this is the main brain box board. Double-sided, good set of silkscreen on one side. The Arduino Nano goes there. Nice organized set of resistor positions there. Transistors. There's the buzzer speaker, the melody chip. One IC. I can't remember what that is off the top of my head. That might be the RTC. There's the battery. For backup. What are the other transistors that drive the LED columns? Yeah, this should be fairly straightforward to put together, especially given that there's a manual. The first challenge, however, is getting this massive board to fit into my board holder. As I said, I think this is probably the largest kit that I've built on the channel. And, well, it is going to present some challenges, I think. And for the parts, I know I always like to just dump them out all willy-nilly, but I think this time I'm going to use this Gridfinity base plate just to dump them into so that they're a little bit contained. I'm still going to be chaotic about them, and that's still going to annoy people, but at least they're not going to go completely everywhere. Okay, if you insist, I'll sort them out a little bit. There's all the LEDs over there. There's all the resistors, the transistors, and the everything else. Happy now? There's also an accessory bag that he sent with it. It's an option to purchase on the website that has the Arduino Nano itself in it, has a power cable, and has a couple of the melody chips in it. They look like transistors, but they are actually little melody generators. We'll set them aside until later. So as this is a bit more advanced kit, I'm not going to go through all the absolute basic stuff like I often do in these kit builds. There's a whole playlist of kit builds up there if you're looking for more basic stuff. But this one I am going to blast through the basic stuff fairly quickly. But as I said, I'm going to start with the resistors. It suggested that in the manual, and that's typically what I do anyway. And because of colorblind reasons, I will be using my meter to figure out which one is which and where they go. So here we go. That's all the resistors in. Let's go back to the manual and see what's next, because I can't remember. Crystal and the 3-pin socket for the melody chip. Okay. Well, the crystal's easy. It goes right there, and I am going to give its pins a little bit of a bend as it shows. I'm not going to do it freehand. I am going to do it this way, just so that they are nice and neat and it lies flat on the board. And then this little melody chip socket is not going to stay there without a little bit of assistance. So I'm going to go back to my old friend Blue Tack. This is just poster adhesive putty stuff. I get mine at a dollar store. You can sometimes find it at stationery stores or places like that. Sometimes under the brand Fun Tack or Sticky Tack or something like that. But basically, it just holds that in place until I've got it soldered down. Next are the transistors and the socket for the RTC chip, which is that 8-pin chip. We'll start off with the socket. As usual, look for the markings, the polarity markings on the screen print. There's a little notch there, and on the socket there's a notch here. Those both indicate the pin 1 corner is over there. So I'll just toss that in, and since it's a bit loose, we'll throw a bit more Blue Tack on there just temporarily. We'll hit 2 diagonal corners and then reach around, pull the Blue Tack off, give it a press with my finger tight to the board, remelt the solder, try not to burn my fingers. There, that should be nice and flush to the board, and then I can get the rest of the pins. And now it wants all the transistors. Normally I would leave those until a little bit after some more sockets and stuff, but since these are just super common, basic little NPN transistors, I'm not too concerned about blowing them up. They're fairly durable, and I've got plenty of compatible transistors in stock if I do happen to damage one. As always, make sure you get them in the correct orientation. Match the pattern on the silk screen with the shape of the package. In this case, we have to kick the center contact back just a little bit to fit the footprint, but that's not a big deal. You may notice that I soldered only 1 pin of those transistors first. Because this kit isn't in a case, everything's going to be in the open. I'm actually putting in a little bit more care and attention to getting everything physically straight and mechanically aligned and just looking a little bit nicer. It's not my usual approach. It doesn't make any difference electrically. But if this thing's going to be on display, might as well put in a hair extra effort. I'm not going to go completely crazy and get it millimeter precise, but I am going to put in a little bit of extra effort. Next up, buzzer, battery holder, power port, and the headers for the Nano. There's the speaker. It's got a polarity marking on it. There's no polarity marking on the board, and the schematic doesn't indicate one. So it is just a speaker. That's the same case that they use for the piezo buzzers. So let's put that in there. Grab the power connector. Where does it go? There's where it goes. The battery holder, again, just match how the silk screen shows it. Those all sit kind of loose. I'll blue tack all of them on there until the solder is holding them in place. Did I mention how easily this board is soldering? I am really, really impressed. Although, I suppose I shouldn't be surprised. I've done a bunch of these universal solder kits, and they are all really, really easy to put together. They may be complex, some of them, but the included parts are high quality and they just go together so easily. Headers for the Nano. Those just drop in there and there. And let's see now, that Nano doesn't have pins on it right now, so I'll just grab another one out of my collection just to use to hold the pins in alignment while I get them soldered. I'm not going to leave it in there for the entire time. I'm just going to loosely set it in there, but I want to have them lined up. Oh, and that wants to follow it too. Okay, I'll use a little bit of Kapton tape just to hold that. I could use blue tack, I could use electrician's tape or whatever, but Kapton tape works too. And I'll just leave that there long enough to get the four corners soldered down, and then I can remove those, and I can remove the Nano from on top. Just make sure that everything's seated and didn't move, and that didn't, so that's good. Get this guy out of the way so that he doesn't get harmed, and finish soldering this down. Fast forward. Finish it up with the 4 push buttons. Don't install the light sensor yet, this will come later. 1, 2, 3, 4 push buttons. And they go over here in no particular order. Down, set, up, and snooze. So that will be for time setting and alarm setting and whatnot. And of course, snooze for snooze. So that board took me about 45 minutes or so to do. I was being relatively careful, consulting the schematic and whatnot, and I don't think I've got any problems with it. So now we will carry on to the more challenging board. Well, the more time-consuming board, which is the LED board. It's not so much time-consuming because it's got all these LEDs on it, although it does have all these LEDs on it. But the time-consuming part is going to be making sure all the LEDs are nice and aligned and straight and whatnot. The other thing that we have to do is try the LED polarity and colors. It says there are red and green LEDs in the kit. Compare with the print on the back of the display PCB. It explains which polarity will result in... Oh, are these dual color LEDs? So there's one direction. Flip him around. There's the other direction. That's very, very dim. We'll try a different one. Oh yeah, so we're red in that direction. And I'm assuming green in that direction. So maybe that one is a dud. I'm just going to put it separately over there and try a few others here. So, okay. Maybe I just lucked out and randomly grabbed the bad one in the batch. I don't really want to have to test every single one of these LEDs, but so far only that one shows up bad. Maybe, I don't know. Hopefully there's a couple extras in the kit, and I'm not pooched about that one, but we shall see. Okay, so it's saying here the LEDs are dual color. They produce green in one polarity and red in the other. Yeah, we discovered that. Depending on your taste, you can have the entire display green or red or the seconds in a different color, or the colon an alarm, or LED, or whatever you think is cool. All right, so I get to make a decision. So I think what this colorblind guy is going to do is make it red, because that's just the classic. And maybe I'll make the colon green, but everything else red. So for red, I need the long lead to pretend to be the anode. In which case, for the colon, I will need the long lead to be the cathode. So I'll just put those two in first. And then the rest of them, the long lead is the anode. Now in here it suggests is to start with the LEDs in the segments. Start with them with segment A, then D, then G. Segment A, B, C, D, E, F, G. Okay, so starting with the horizontal bits first and then doing the verticals. And it says to solder only one lead of every single LED, then line everything up, and then trim those soldered ones, followed by soldering the second lead of each LED. So I guess I will have to just follow along. And I'm noticing that the anode and cathode, some of them are on the right, some of them are on the left. So I'm having to actually pay attention here, which means I will go quiet and blast through this and come back to you once I've got, well, basically once I've got that step finished with all of the one lead soldered down, and then we'll see how straight these things go. So now that I'm about halfway through doing that, I've got all the horizontal ones done, at least with one pin. I've got myself into a bit of a rhythm. I'm dropping in 4 in a row, first of all, just getting them all in place, making sure to pay attention to the anode and cathode and get them all consistent, because it switches every second one is either anode on one side or on the other side. I guess that just makes the circuit board layout nicer. So I got 4 in, and put a blob of blue tack on just to hold them. At one point I was trying to hold them with a finger while holding the solder and the iron, and that just wasn't working out for me. But now with the blue tack, I can get one lead of each one soldered down as the instructions suggested, which is usually how I do it anyway with something that needs to be, you know, in alignment, just for prettiness. I'll peel that blue tack off, and you notice how they're all cattywampus. Then I'll put a finger on the LED, push it right tight to the board, remelt it, hold it there until the solder hardens, and hopefully they all come out nicely aligned. Like that. Pretty close anyway. Close enough? Yeah, close enough that I'm happy. So I am going to continue. Actually, I think what I'll do, rather than continuing with these vertical ones, I think I'm going to finish off the horizontals. So just make sure that they are all in alignment like it said, and I'm pretty happy with all the horizontal ones. I will then chop off the lead that I've soldered so that that's not in the way of my iron and my progress. And we'll solder off the second lead on each one of those and carry on. So far I'm about half an hour into just soldering LEDs. I expect this to take at least another half hour. Well, no, probably 15 minutes to get the second lead of all those, another half hour to get those ones in, another 15 minutes there, and then probably about half an hour to get those ones done. So I will spare you my yammering and come back to you when I have all these LEDs done, because when that happens, we're getting pretty close to the end of the project. So there, that is all of the LEDs. And if we look back here, I've got 3 good LEDs left, the one bad one from the beginning. I have the light sensor and the What are you? Oh, you are the real-time clock chip to do. And I guess I've got to deal with the Arduino. But let's go to the manual and see what the next step is. After both PCBs are fully assembled, we need to marry them. I don't know whether I've got the qualifications for that. Set the mainboard PCB into the slots of the display PCB at a 90-degree angle and connect the outer two pads with a blob. Check if everything's straight and then continue to do the rest of them. I think I'll do that flat on the workbench after I clean up all of these trimmed off leads. Wow, that's a lot. So those just go like that. Those tabs kind of go that way. So he wants me to tack the outer two pads. I think I'm going to do the first one without any regard to the angle of the dangle here. Tinned on both sides. Does that hold? Yeah, it does. Okay. I think I'll just set that up that way and reflow it a little bit to get the angle a little bit more 90-ish. How close are we? Not very. Okay, well, I'll tweak with that a little bit and get it lined up and then carry on. I didn't notice before that there's also pads on this side which are a lot easier to get to. I'll blob a bunch of solder in there. I think that's better. Yeah, I'm going to accept that. Now I'll just do the one on the opposite end here. Nice big blob. Yeah, that'll do nicely. Right. After that, I'll just do the rest of them as instructed and come on back to you. There we go. All nicely solder blobbed together. I think adding these little fillets in the back here will be good for mechanical stability. I don't think they're necessary for electrical though. I actually was able to get down in between there. It's not pretty, but it did the job. Oh, it's a good thing I did do both sides because it says to proceed with all connections on both sides of the board. Okay, done. Even though I wasn't paying attention. Next, photoresistor. You have to bend its leads into a certain shape to make it fit in the spot so it can see through the hole. Light sensor is for a possible future upgrade. It's not used in the demo code, but you could add your own if you want to. Right, I'll put it in anyway. So the certain shape for this basically means that has to sit at the front there and then it has to bend so that it goes down through those holes there. Right. Hopefully that does it. And then can I get it into the holes? Okay. So that works, and it needs to be held up just a little bit. So I will do that and stuff some blue tack in the back of there. Solder that down, and hopefully it stays in the right place. Maybe I'll do one lead and then just check. That looks pretty good. Yeah, okay, I think that'll do. Just a quick touch on the other pad. Well, that appears to be the end of the instructions. There's a couple more things that we need to do, though. First being to put in the real-time clock chip. DS1307, one of the two most common real-time clock chips that you see in Hobby World. It goes in with the notch on the chip, matching the notch on the socket, which matches the notch on the silk screen that we saw earlier. Plonk, there it is. That crystal helps it keep time. That battery helps it remember it's time when we're powered off. The other thing we need to do is put the pins on this Arduino Nano. And for that, I will use my most abused breadboard just to keep the pins in alignment. I'm pressing down with one finger. Just get a couple of corner pins soldered up here. Spin it around, do the other two corners. And then everything's held rigidly in place and I can zip along and do the rest of the pins. And while I've got that on the board, I think I will program it up. As I mentioned earlier, the sketch is linked right here from the page that I'll link you down below. So here is that demo sketch that was provided. I'm not going to go through it line by line, but I did go through far enough to see that it needs these libraries, and I verified that I do have them installed. So, upload we go. While that's happening, I'll just scroll through this. You can, of course, download it from the link below and take a closer look yourself if you choose to. Oh, it's done uploading already. Oh, that was fast. Hopefully all my pin alignments work out. Yeah, that looks like it belongs. Cool. The other thing that I want to do before I power it on is there are these two little melody chips that were in the optional accessory bag that he sent me. They are 66T19LK RK9 and 66T11LK. I guess there should be no surprise that he's actually got the melody chips on his website too for $1.99 each. So the 08 is happy birthday. The -19 is for release. The -OA is Jingle Bells, and the -11 is Love Me Tender. I think I'll use the -19 for release because that's less likely to get me a copyright strike than Love Me Tender. Although I can change it because it plugs into a socket. It is the same D-shaped screen print on there, so that makes it easy to know which direction to plug in this little package. So I'm being a little bit brave here, plugging it in with the chips in and the transistors in, but let's just see what happens, shall we? We got power there, that's good. Nothing there. Okay. So we'll just plug this in the dark here. Hey, look, we have a display. Arduino 2139. Cool. It's doing the thing. Let's push and hold the set. Adjust time, yes. The time right now is 22:31, so let's set that. I do have an RTC battery in it, so hopefully it'll hold. Let me just mess with it a little bit. Okay, so that is the actual time. I'll push and hold and push and hold and push and hold. I don't know. Okay, there we go. 1912. Set what? There wasn't any instructions on the menu system. I'll probably have to pull that out of the code. Well, that's the alarm. Okay. Anyway, I'm just going to reset this thing. And, yeah, it does the thing. The software I have to figure out, but hey, look, it held the time. Excellent. If I was as polite as Big Clive, I would have given you a warning that the lights are coming back on, but I think you probably survived. So this is a neat little thing. It's obviously not intended to be run in bright daylight or ridiculously bright filming lights like I've got here, but in dim light it works great. It's easy to view. It holds the time, which that's what the RTC with a battery is supposed to do. The only thing that's confusing is the menus a little bit, is I'm having trouble understanding the letters that are being displayed on these digits. They're not really designed for displaying letters on, but it's doing it anyway. But that is all in the code, and if I spend some time in the code, or if you guys want to, that is going to let me figure it out. Well, that was fun to put together. That was a nice evening's relaxation, and it did take most of the evening to put it together, but as you can see, it's working. It does the thing. I didn't figure out how to run the alarm modes so that I could play the music, but That, like I said, is going to just take some digging through the software. But the hardware works, and that is all I'm really concerned about, because that's what the kit is all about. At least for me it is. I'll go through and deal with the rest of it later. Thanks for watching. As usual, questions and comments down below. There will be links to this in the description. And yeah, thanks for watching all year. This is the last of my December kit builds. In January, I'm not quite sure what I'm going to be doing. I'll probably be tearing into some of the stuff that I've got in mailbags. I've got a project to do that makes use of that resin printer. They asked me to do another video on that, so that'll be coming up in January at some point. And just more shenanigans with more interesting beer. Thanks for watching. I already said questions and comments down below. You know that. I will talk to you later.